Yes, welcome to Section 2 of Built-Up Roofing Damage Assessment. In this section, we're going to focus on installation and roofing design issues. First, starting out with the application of the bitumen on the roof. Then look at the different surfacing options for built-up roofing. Then some common details on built-up roofs, and then some of the design and application issues that you're going to see as an inspector. First, in looking at the application of the hot bitumen, for asphalt, there's been a determination of what is known as the EVT, or equiviscous temperature point. This is the ideal temperature at which to apply our hot bitumen to the roof. And there's a technical definition there that is described on the slide, but essentially it's like the viscosity of warm syrup, and who doesn't like warm syrup? The challenge for the installer is to keep the right temperature and going from the kettle where the asphalt is being heated to where then it's pumped up onto the roof and put into carts and buckets and then applied to the actual roofing membrane. The most common surfacing for built-up roofs is aggregate or gravel. And in fact, one of the common names for built-up roofing is a tar and gravel roof. The gravel or aggregate adds weight and also provides some UV protection for the asphalt. What aggregate materials used may vary just on your geography. What are common aggregates and rock materials available? Is it river gravel, crushed limestone, slag, lava rock, marble chips, and even others you may see? The hot flood coat is going to be applied on the top of the built-up roof at a rate of about 60 pounds per square, which is roughly 1/8 of an inch thick. Then our aggregate would be applied at about 400 to 500 pounds per square. The ideal is that aggregate is applied when the flood coat is still hot, so you can get approximately 50% of the gravel actually embedded into the bitumen. The rest can be on the top loose, and that's part of the proper design to have some embedded and some loose gravel. Gravel or aggregate is not the only surfacing that can be used. If you want to have a lighter colored material, after the flood coat, there are many different types of aluminum or reflective coatings that can be applied, such as is shown in the photograph on this slide. If you're looking for a white color, you can use a polymer, such as acrylics, applied to the top. Some parts of the country where you are not allowed to use loose gravel surfacing, particularly in the hurricane coastline areas where they've got high wind design. If you don't want a lighter colored roof, there are some darker colored coating options. One is known as the emulsion, where the asphalt is thinned out with water and also may have some fiber content. Cutback is when the asphalt is thinned out with solvent, and it also can be reinforced with fibers. Another option is to apply a cap sheet. This may be done for aesthetic reasons, to have a white granulated surface as opposed to gravel or a reflective surface. This cap sheet normally is a one-ply installation because the structure or strength of the roof is already being provided by the felt plies. A granule surfaced roll roofing fiberglass could be used, or it could be a granule surfaced modified bitumen roofing. Another option with modified bitumen is foil faced. And in the photographs we are showing the granule surfaced glass cap sheet. In examining some of the common roof details, here we've got two views of a short roofing curb. In looking at the detail on the right, it shows that the multi-ply built-up roof is going to go up that 45-degree curb to where it terminates near the top. Then asphalt plastic cement can be installed before putting on an additional flashing ply of material up that curb. That would be attached with fasteners. The fasteners would end up being covered by the metal edge flashing, and the metal edge flashing fasteners will be installed in the sloped portion to give it better water resistance than if the fasteners were in the top of the edge flashing. Next, we're looking at a short parapet wall. At the base of the parapet, a 45-degree cant strip is installed, And the built-up roofing plies will transition from the low-slope roof up the cant strip and then a little bit up into the vertical portion of the wall. After priming it, another single-ply flashing material that could either be modified bitumen roofing or a fiberglass roll roofing material would be installed going from the flat portion to the cant strip up the vertical part of the wall and then be fastened near the top of the wall. The top of the parapet is covered by metal cap flashing, also known as coping. The photograph on this slide shows a cant strip during installation. The purpose of that cant strip is to create 45-degree transitions. Asphaltic or coal tar built-up roofing does not have enough flexibility to make a 90-degree turn going from a flat roof to a wall. So the use of cant strips makes that transition more gradual and also provides support for the roofing material. Next, we're looking at a wooden curb. This could be used for a roof access hatch, or possibly equipment would be installed on top of it. It's somewhat similar to the curb at the perimeter of roof, where the built-up roofing felts would come up the cant strip. You'd be covered with another layer of flashing material, and then the top is covered by a metal cap flashing. Note that the fasteners are in the vertical portion of the metal flashing. This slide shows the detail from a plumbing vent stack. The multi-ply built-up roof will extend all the way to the opening for the vent stack. Then the flashing sleeve is installed and extends over the built-up roofing plies. A primer would be applied on top of the flashing sleeve, and then you would hot mop an additional ply, known as a stripping ply, on top of the flashing sleeve for optimum water shedding ability. What's shown on this slide is actually a structural problem, not just roof related. We've got light and dark colored bands going across this roof. The light colored areas indicate high points, and the dark colored areas low points where water regularly collects and grime is accumulating. This was over a tectum decking, and it clearly did not have sufficient structural support. This is a problem that you might have to get an engineer or some other type of structural expert out to look at and look at some things underneath the roof support structure. In examining the way a built-up roof is mopped together, you want to have 100% coverage of the ply to its adjacent ply. After that hot mopping is done, they broom or squeegee the plies to make sure they are locked together and not have any voids or dry spots between them. That void can turn into a blister with time. And so part of the control is looking for a run out or bleed out of asphalt. The photograph shown in this slide indicates some problems. We've got wrinkles where a pen can be slid underneath that felt without asphalt contact, and there's very little bleed out being shown. The photograph in this slide shows alignment of the end joints. They all ended in approximately the same area, and so you end up with this horizontal plane across the roof that is going to be weaker. And as you go through thermal expansion contraction cycles, you might be likely to get cracking or splitting of the roof in this area. When you're going from one end joint to the other, you want to offset at least 6 inches. If you see a dissimilar material in the middle of your built-up roof, there's a chance it might be a splice from the manufacturing process. When they get to the end of one roll of fiberglass felt, they use a cloth iron-on patch to join the two pieces together, and that should be pulled out at the end of the roofing line, but it doesn't always happen. If you've looked at a lot of asphalt shingle roofs, you may have seen something similar, and that's what's illustrated in the photograph in the lower left. And a similar thing can be found sometimes on built-up roofs. With long-term thermal expansion contraction, sometimes you can end up with splits in your built-up roof. This also can happen at changes in the building structure, or if the building is quite large and doesn't have expansion joints. And Mother Nature has a way of putting in expansion joints if we didn't have the foresight to design them and build them in ourselves. Here we're looking at a lower level roof section that abuts an upper level corner of a building. The dotted yellow line indicates where an expansion joint would have been helpful, although it was not put in. And so as a result, the roofing below has been splitting and has had to be repaired on multiple occasions. A similar situation is shown in this one. The lower level roof intersects near the corner of the upper portion of the building, and prior repairs have been done in this area. Again, this dashed yellow line shows an area where it would have been helpful to build an expansion joint, and that would have prevented that splitting from occurring. Another place you commonly get cracks with thermal expansion and contraction is at the re-entrant corners of a building. And this is primarily because you have two metal edge flashing pieces that come together, and these are going to expand and contract and put stress on the built-up roofing at that point. And you commonly will get a crack that forms at a 45-degree angle to that corner. In both these photographs, we're looking at repairs that have had to been done in these cracked areas. Here's a detail of what a proper roof expansion joint would look like. And this expansion joint goes all the way down to the roof structure. So area 1 is separated from area 2, and a compressible material is put in between the two so they can move completely independent of each other. The top of that expansion joint has a flexible but waterproof material, and on either side the roofing goes from the low slope above the cant strip and to the vertical plane where it is terminated and covered with the cap flashing. Typically, when a building is longer than 200 feet, or you've got changes in the roof building dimension or shape or building usage, it is helpful to put one of these expansion joints in. You also would have to check your local codes to see what is the proper dimension in your area for expansion joints. This concludes section 2 of our course. We'll now proceed to your review and quiz.